6:15. So we got the Shroud tells me I'm 2 minutes late. So we gotta get you started. So
Okay.
all right, take it away.
Okay, now. Well, there's my title. Whoops, that's nice. I'll start out with John Jackson and the Jumpers. You've probably all seen this. They used a VP8 analyzer to show that the image intensity could be converted into like a contour. So it indicated that there was a relationship between the intensity of the image and the distance away the shroud was from the body when the image was formed. I'm going to be talking a lot about fibers. I think I'm going to point at, well, see, where's everybody? I think I'll stick over here. Whoops. The image on the left is a clear cloth. Image on the right is where the image is. And you'll notice there's striations. And that's very important. In addition to that, the image is only on the topmost fibers. Just the topmost fibers. They call that superficiality. All of the fibers are the same color and intensity. The only difference is where it appears to be darker, there are more of those image fibers. The image fibers are 13 micrometers in diameter, very thin. The darker regions are more fibers. And the image fibers are topmost on the thread, topmost. And what that means is that they are on the top. No fibers that are colored are underneath other colored fibers. And they're only colored on the outer surface. It turns out that they were dipped in a reducing agent, and instantly the colored fiber turned just normal color, indicating that it was only on the surface. And Alan Adler said that there was no paint. The color of the image was caused by oxidation and dehydration of the cellulose, so no paint. And then I pointed out the image appears striated. The sad thing is that it dated to 1325. And then Moroni and Renaudot experimentally demonstrated that the age of the shroud could have been reduced by neutrons that would interact with the nitrogen in the shroud to form carbon-14. And then Renaudot, and what I'm going to be doing now really sort of follows on Renaudot. He showed that protons, if they were released during the resurrection, would produce the coloration that's seen on the shroud. And he then proposed that during the resurrection, Christ's body gave off neutrons and protons. And then Giulio Fonte observed an image on the reverse side of the shroud, and that's something I'll touch on. Well, everything's made of atoms, you, me, Christ, and the idea is that when Christ was resurrected, the neutrons were given off to change the radiocarbon date, and protons were given off to cause the image. Here's Renaudot's 1.4 MeV proton studies. What MeV means is million electron volts. It's passing a proton through an electric field of 1,000 or 1.4 million volts. And here he shows that, whoops, let's go to here. Whoops, come on. We'll get this light. Here he shows that it's superficial. In other words, at the center of this fiber or thread, it's white on the inside. And I'll show you that the images I obtained are more like on the Shroud, but they're superficial. Here on the left, you can see that there are these lines that run along the fibers where the color is. The color doesn't go perpendicular to the fibers, but runs along the fibers, and that's called striations. And this is what Renaudot produced with his 1.4 million electron volt protons. And you don't see that striation here. And I don't know how far away he was from the proton beam, but he used 1.4 MeV. Now, since the image only goes one fiber deep, I concluded that since the fiber is 0.0013 millimeters thick, the proton cannot go any farther than 0.00313 millimeters. So that's the greatest depth that the proton can go. Well, a 1.6 or 1.4 MeV proton will move along and it'll die out after it goes 0.006 millimeters. And jumping over to here, we see that the 0.4 MeV proton will only go the width of a fiber. So I conclude if protons made the image, they would have to have an energy of 0.4 MeV or less so that it only colors the topmost fibers. Then we get into the decline of the proton energy in air. Now, even though the 1.4 will get down to 0.4 MeV, if we have 1.4, well, there's a good chance that it's going to hit the shroud before it goes through the air. So I'm limiting myself to 0.4 MeV so that it definitely will only color the topmost fibers as are seen on the shroud. And here's the distance that then, in other words, this 0.4 MeV in going through air, it's going to peter out in 4 inches. So if I limit myself to 0.4 MeV protons, then the source of the protons has to be within 4 inches of the shroud. Saying that again, if Christ gave off a 0.4 MeV proton, the shroud would have to be within 4 inches of Christ's body in order for the image to be formed. Let me go back here. I talk about this 4 inches. There's a good example of the 4 inches in the next slide. Whoops, come on. Here's Christ's hands. Here's his stomach and his legs, and he's got them crossed. And just today, I crossed my legs, and I had my wife measure what's the distance from the bottom of my hands to the back, and it's just about 4 inches. So there's an image here on the back of the hand, but there's no image there. And I just told you that it wouldn't go 4 inches to make an image. And it wouldn't go 4 inches here or here. So that's kind of an indication it could have been protons. This is something that I annoyed my wife with. I had her lay on her back, and I took a cloth and put over it, and the cloth had a checkerboard square on it, and in the middle of each 1 inch by 1 inch square was a hole, and then I'd poke something down, and when she yelled, I put my thumb there, I pulled it out and measured it to see how far away it was from the shroud. So this is so I did that, and without going into all the detail, I found out that the thing could not be suspended above the body because it's more than 4 inches. Even here is a problem because from the cheek up to here would be a very dim image with protons. Now, if it's draped slightly, it'll give an image, but it turns out that it's still far enough away from the cheek that the cheek doesn't show up very well. And it would produce a narrow cheek image or in the face. And you see here that you know that Christ wasn't emaciated, but you see how skinny his face is, like he didn't have a good meal for a while. And so what you saw in the previous slide was in here, the shroud was really too far away to get a good image on the cheek. So now we get to experiments that I performed. I used the cyclotron at the University of Missouri, and unfortunately, let's go back. Unfortunately, this was 16 million electron volts. Remember, I just told you that Christ's body didn't give out protons if they were greater than 0.4. So that was a problem. So it turns out the way I did that is I took linen samples. It was placed behind lead and or tin plates to reduce the proton energy. And I had multiple layers of linen behind those plates. And unfortunately, the imperfect knowledge of the properties of the linen, I know the chemical composition of the linen, but the linen has holes in it. There's air. So if it would have been a solid piece of cellulose, I could make an accurate calculation. But because it had holes in it, I didn't know if my calculation was going to be right. So what I did is I added a lot more pieces of linen behind that, so I managed to get the energy down. And then another thing. With the cyclotron that I used at the University of Missouri, I could not adjust the number of protons per square centimeter. If they'd been able to crank it down less, that would have been nice. But I knew that I was going to get more than I should. But as luck has it, I was able to do that. I'll discuss that. Here's my result with 16 MeV protons. So it was essential that I got it down to 0.4 MeV. This is a typical sample. Let's go back. There's 2 layers of lead, 2 layers of tin, and then 5 layers of linen to reduce the proton energy. And I ended up using lead. I'll jump ahead and say that I was going to do a number of experiments, but I only got one experiment and the cyclotron broke. So the one that I used, and it worked okay, I had 4 layers of lead, 1 layer of linen, 2, 3, 4, and you see the energy starts out at 16 MeV, And every layer it goes through, it loses energy. And you notice it drops energy very fast at the end. And I didn't know if my calculation was going to be right, so I added a fifth layer of linen just to make sure. And I'm glad I did. So we had that run, and the cyclotron broke. Now, no image was visible at that time because we've talked about this earlier. To do matter of fact, see, if Christ's image was on the shroud due to protons, nobody would have seen it after the resurrection, if it were protons, because it takes years for the damage that the protons did, and along with the oxygen in the air, to cause the image. So the typical way to do that, chemists do this all the time. If they don't have enough time, they heat it up to 150 C for 10 hours, and that reduces the time by roughly a factor of 3,000. So I'm saving 3,000 times the time I would normally have to use, it gets into the years. So, as I said, this would be the reason the shroud image was not visible and it wasn't mentioned in the Gospels. This is the back of linen 4. Now, you'd think if it's going to be close, it would be the most intense. But let me go back to this. You notice that the energy is dropping off. So this linen uses a little bit of energy. That loses more energy. That loses more. And the fourth one, bonk, takes up a lot of energy. So it's the pieces at the end, just before it stops, that gets the most energy. And that's what I showed here. Here's the one that's close up, and you hardly see anything. And then here you see, that's the back of linen 4. Notice it's the back, not the front. So protons made it through 4. Hit the front of 5. And at the back of 5 is where I get the most intense image. And I wish I'd put 6 layers of linen, but I didn't. Here's a view. Let me go back. Like I said, I could not adjust the number density of protons because the cyclotron wouldn't go down far enough. But right here at the edge, the beam is actually only this big, but as it goes through those layers of linen, it gets bounced and spread out, so that the density of linen of the protons I noticed other people had the same problem. It peters out here, and I'm going to show you this area here where the proton density is not very large, because this is much more than on the Shroud. If you've seen the Shroud, you can hardly see the image. It's very faint. So I'm going to look right in here. So this is where we had a lot of radiation of protons. Over here we didn't have any. And right in this area here, we get kind of the number of protons that we think were on the Shroud. And here we see striations, and I will, the next slide will be better to demonstrate this. This is the Shroud. Notice that the colored fibers run along the length of the fiber. You don't get streaks of color this way. It's always running along the fiber. And you'll notice that all the colored fibers are the same color. Here, in my experiment, all of the fibers that are colored are the same color, except there are more over here than here, and right along in here, you can see that striation effect. See here on the shroud, here you get the striation. Here you get striation. Now it's sort of funny because you'd think if the proton beam, I mean protons are small, you'd think that they would do the same thing to this as they did to that, or they did to this. But for some reason, it's just the colored fibers are just kind of bundled up together, called striations, like seen here. I don't know. don't know why that is. I'm trying to figure out why that is. I know I have a proton beam, and the protons are very small and they're uniformly distributed. Why do they make an image that is a lot of them here, not so many here, some here? I don't know. Okay. I started out asking whether, I started out by talking about the characteristics of the image on the shroud. Now I'm going to ask, did I duplicate that with protons? All image fibers are the same color and intensity. I showed that. The darker regions are caused by a greater number of image fibers. I did that. Image fibers are topmost, and I think you probably saw in what I've shown you that they were topmost. The color of the fiber was caused by oxidation and dehydration of the cellulose. Well, I didn't prove that, but Renaudot did that with his proton-irradiated samples, so I saved some time and I didn't have to buy diamide, but he's proven that. And the image fibers are colored on only the outer surface, the outer 0.2 of a micrometer. That means the fiber itself, which is really small, only the outer surface is colored. And he did that because when he put it in the diamide solution, bingo, as soon as he put it in, the color is gone. So that says that the coloring is right on the very outside of the fiber. And then the image appears striated. And you saw that. So, conclusions. The visually observed properties of the image fibers on the shroud of Turin can be duplicated by irradiating linen with high energy protons. And when I say high energy, I mean somewhere in the range of 0.2 to 0.4 MeV. And it's got to be just that. If it's more than 0.4, then the fibers below the topmost fibers would be colored. And we didn't see that with my experiment. The experimental density I used was 6, easy way to say it, 6 with 12 zeros behind it, protons per square centimeter. And the striations seen on the shroud were seen at the edge of the proton beam where the density was less. In other words, that was in the middle of the beam. When I got off, and I didn't see striations here, but when I got off to the edge of the beam, that's when I saw the striations. So the proton density has to be just right to get striations. And I don't know what causes the striations. And then the bottom line is that the proton energy and density must be perfect to obtain the results seen on the shroud. And that's it. Yeah, questions?
Anyone have a question? One question. Answer. No question. No questions? Oh, I have one question.
You thought you had a question. Oh, you got one. Wait, you got to turn the mic on for her.
How do you explain that on the linen sample number 5, you had a color variation